Hi everyone. Today's topic is advanced behavioral modeling. In the previous topics we have discussed about basic behavioral modeling. So the difference between the basic behavioral modeling and advanced behavioral modeling means in basic behavioral modeling we will do some basic actions. In this advanced behavioral modeling we will do some in detail actions like some advanced actions. In basic behavioral modeling, the diagrams are interaction diagrams like communication diagram and sequence diagram, activity diagram, and use case diagram. So all this diagram deals with basic actions. Whereas in this advanced behavioral modeling, we will discuss advanced actions. This is the unit 5. It consists of these four topics: event and signals, process and threads, time and space, and state chart diagrams. So if you see the first three topics like event and signals, process and threads, and time and space, all these topics are useful for state chart diagram. So these all three notations or symbols which is useful for state chart diagram. In today's class, we will discuss about events and signals in detail. Right. So first of all, what is an event and what is a signal? So we will discuss what events and what signals are. Then we will go through that topic. Okay. Now now the introduction. So what is an event? What is an event? Generally, any any kind of occurrence is an event. In UML, this event is nothing but it is specifications. It is a specificance or significance of occurrence which has time and space. Right? For event to happen, we need some time and we need some space in UML. This event may be synchronous or asynchronous. The difference between synchronous means when there are two objects, one object send request to other object. If we get the response, then we can say it is a synchronous event. When we doesn't get a response from other object, when there are two objects, one object send a request to other object. If there is no response, then we must say it as a asynchronous event. So, so I told you what is an event. An event is a significance of occurrence, specification of occurrence with time and space. It may be a synchronous and asynchronous. So if you see this an example for an event, so consider a telephone when it is in active state. If you want to make it the telephone into idle state, so using a half hook or if you use this operation like drop connection, if you drop the connection, then the telephone will be in idle state. Since this is an event, so this may be synchronous, which means there is no acknowledgement here. There is one way. This is a asynchronous event, right? In the similarly, signals are, you see the send the signals are asynchronous event, which means when there are two objects, one object sends signal to other object. When there is no response from the other object, then we can say these are signals. There is no notation for signal in UML. That's why we have used the stereotype symbol, the angle brackets, and make it this half book as signal. This means this half book is a signal. Okay. Generally, there are two kinds of event. One is actional event, and other is the internal event. So what is an external event? The events performed by the actor and the system is a actional event. For example, there is an ATM machine, and user, a user he will withdraw the money. He can insert the card. He can enter the PIN number. All these are actional events. These kind of events are actional events. Similarly, when there is an exception while running a program in the ATM machine, all these exceptions are internal events because these are done within the system. Okay. According to UML, there are four kinds of events. One is signal, as I told you, another is call, other is time, and other is change event. These are all the four kinds of event which is used in UML. First of all, what is a signal? What is a signal? A signal is a asynchronous event between two objects. We can say like that. Consider one object and other two, object one and object two. When we send a signal to object two, if there is no response from the object two to the object one, then we can say it as a signal, right? So that's why signal is an asynchronous event, which means there is no response or acknowledgement from the object two. So this is an example for signal. Here, this movement agent class is sending signal to collision class. So a signal signal is similar to class which has some attributes and operations. Here the signal is a collision signal. Here the moment agent class which consists of attributes position and velocity, and using this move to operation it is sending signal to this collision class. Next one is the call. This call, this signal is a synchronous event, whereas this call is a synchronous event. Why? Because consider two events. This object one is calling an operation from this object two. If this object two gives the response, or this object one is receives a response from object two, or the object one is received a acknowledgement from the object two, we can say it is a call operation. If in order to do a call operation, call event, we need two objects. One is for sending and other is for receiving. This is an example for call event. So there are two states. We can consider a mission. We can start it by manually or automatically. If we want to start the mission automatically, we have to invoke the start autopilot operation. This manual from this manual state, it is invoking an operation on the automatic state. So then the machine will start automatically. Since this is a call event, it waits for we have to wait for the response from the other object. Next, the acknowledgement is missing here in this diagram. Next, time and change. The next one is a time event is an event that represents passage of time, right? Similarly, the state event is a state. The state event, change event is nothing but a change in state or a condition, right? Right. So if we see this example, both the time event and the change event is explained is in this diagram. If you see, whenever using this after keyword, whenever 2 seconds has passed, this is a Boolean expression. After 2 seconds has passed, the telephone which is in active state will comes to idle state. This is whenever 2 seconds is after 2 seconds. Whenever there is a passage of time for 2 seconds, this is a time event. The telephone from active state to idle state, it will go to idle state. For example, okay, next change event, the last event, change event. Whenever a time changes to 10 p.m., using this when keyword, we have implemented this self-test operation. Whenever the time is 10, whenever the time is changed to 10, this machine will self-test it will test itself, right? So these are the four kinds of events. Next is the sending and receiving. We can send a signal or receive a, we can send information and receive information between the objects. This is a class. These are all the signals. Since these are signals, there is no two-way response, only one-way response. Since it is a asynchronous, signals are asynchronous, right? Next are common modeling techniques. Using these signals, event and signals, we model the family of signals, and also we can model the exceptions, right? So there are signals, right? There are, first of all, we first of all we have to know, or we have to identify the kind of signals, different kinds of signals which is used in this robot. After identifying the signals, we have to form a hierarchy like generalization and specialization hierarchy. This here, if you see this robot signal is a signal. You have all these classes are mentioned using the stereotype signal. This robot signal is divided into two types of signal. One is collision signal and hardware signals. What are the different hardware signals? Battery signal, movement signal, vision signal, and ranging signal. Right? This movement signal again divided into forms a generalization and specialization hierarchy as motor stall. Using this event and signals, we can also model the exceptions. Right? If we see this is a class item set class which is useful for storing an items. It contains two operations like add operation and remove operations. It can as it contains add operation, it can add elements into the set. So whenever this we are trying to add a duplicate element which is already present in the set, we are trying to add, then this duplicate exception will be raised. Whenever we are trying to add, whenever the set is full, even though we are adding one more element, then this overflow exception will be raised. So here we are sending the signal using send stereotype. So whenever there are no elements in the set, we are trying to delete an element, then this underflow exception will be raised. These exceptions, generally we have to identify all the exception. After identifying the exception, we have to form generalization and specialization hierarchy. If you see these operations this operation will be executed, will depend on this exception. Right? This is a dependency relationship. That's it.